Imagine stepping into a car that supposedly powers itself. No fuel, no plug, no charging station, just motion. That's exactly what happened when we tested Maxwell Chikumbutso's self-powered vehicle. At first, it felt like stepping into a rumor, a myth that refuses to die. But within moments, the experience turned into 7 discoveries so strange that even the skeptics among us had to sit down. What we saw wasn't just unusual, it challenged engineering logic, modern energy theory, and our assumptions about what's possible. And with each minute behind the wheel, the story only became more unbelievable. The first moment felt wrong because everything felt too normal. We sat inside, pressed the start button, and waited for the familiar hum of an ignition system or the quiet click of an electric relay. Instead, the car simply came alive, as if waking from sleep. No battery warm-up, no boot time, no delay. According to Maxwell, the car uses an RF-based energy harvesting system that converts radio waves, magnetic fields, and ambient frequencies into electrical power. Whether you believe that or not, the car's reaction was smooth and instantaneous. But here's what made the room go silent. The diagnostic panel indicated 0 external input. There were no hidden cables. No generator tucked somewhere, no charging port. We even checked underneath the chassis, nothing. The team verified that the main battery was not connected to any external source, and yet the dashboard showed stable voltage. This was the first moment people started whispering. Not because a car started, that happens every day, but because every logical path for how it started was blocked. And when logic runs out, curiosity kicks in. That curiosity is what pushed us to keep going with the test drive, hoping the next discovery might expose the trick, or reveal something genuinely new. If the starting process raised an eyebrow, the next discovery raised all of them. During the first few minutes on the road, we watched the battery percentage, expecting it to drop slowly the way it does in any electric car. Instead, something impossible happened. The reading went up. At first, everyone assumed it was a display error. Maybe the gauge was stuck, maybe the calibration was off. So we pulled over and checked the onboard diagnostics. According to the internal system, the output voltage coming from the RF harvesting module exceeded the vehicle's energy consumption. In other words, the car was feeding the battery faster than it was draining it. This is the moment the test stopped feeling like a demonstration and started feeling like an argument with physics itself. A system generating more usable power than it consumes? That's not just unconventional, that's something textbooks would call impossible. We repeated the test 3 times. Each time, the battery gained a few percentage points during motion. The car essentially behaved like a moving power plant, quietly charging itself as it accelerated. Whether you interpret this as breakthrough engineering or an unexplained anomaly, one fact became undeniable. Something inside this machine did not obey the rules we expected. Most engines heat up, gas engines burn fuel, and electric motors generate thermal buildup from resistance. But Maxwell's car didn't. We monitored temperature readings at idle, during acceleration, and after sustained driving. The numbers barely shifted. Touching the engine housing was even stranger. It felt cool, almost unnaturally so. Even at maximum load, the temperature stayed within a narrow band, as though the system refused to waste energy as heat. One engineer with us said, "If this is real, it's not just about free power. It's about perfect efficiency." A bold statement, but not an unreasonable one. The energy module supposedly stabilizes frequency and converts it into torque without the usual losses associated with magnetic resistance. If that's true, it would explain the cold engine. But standing there, resting our hands on a machine that should be warm, the experience felt eerie. Machines aren't supposed to behave like that. This wasn't a party trick. No cooling fans blasted air. No refrigerant lines coiled around the block. No hidden coolant system hummed in the background. The lack of heat didn't just hint at efficiency, it hinted at a technology that doesn't belong in the same category as combustion or electric motors at all. Something fundamentally different was happening here. The next discovery came during a controlled energy measurement test. We expected fluctuations, every power system has them, but the output remained remarkably stable. More stable, in fact, than conventional EVs under similar load, without fuel, without charging, without loss. The energy output graph was a smooth, unwavering line, as though the car operated on a tap that was permanently open. The team tried to trace the wiring, expecting to find a hidden auxiliary battery or a concealed generator, but the lines traveled directly from the RF conversion module to the motor controller. The module itself was sealed, its internals inaccessible. Maxwell explained that it contains proprietary circuitry capable of capturing a spectrum of frequencies and converting them into rotational energy. Whether or not you accept that claim, the performance was undeniable. One engineer kept repeating, "No drop." "No sag," another said. "This shouldn't exist." The longer we watched, the more unsettling it became. If a device produces stable power indefinitely without consuming an equivalent resource, then every assumption about energy infrastructure becomes questionable. This wasn't just a discovery, this was a confrontation with the unknown, and it set the stage for something even stranger. If the car simply powered itself, that alone would be historic. But during one of the deeper diagnostics, we saw something that pushed the limits even further. The car generated excess power more than the drive system required. The surplus was routed to an auxiliary outlet capable of powering external devices. We plugged in lights, then a drill, then a small refrigerator. Each time, the system adjusted effortlessly. In most vehicles, diverting power would reduce performance. Here, nothing changed. Acceleration stayed smooth. Battery voltage stayed constant. The power module behaved like a generator with no fuel tank and endless stream of output. One of our technicians stared at the readings for nearly a minute before saying, "This isn't an engine. It's a power station on wheels." The implications were staggering. A vehicle that powers itself is one thing. A vehicle that could potentially power a home? A farm? A clinic? That's a different level entirely. It raised a bigger question. If this technology scales, what happens to the industries built on selling electricity, fuel, and infrastructure? The car wasn't just self-sustaining, it was producing abundance. And abundance changes everything. Most machines degrade over time. Pots heat up, friction increases, and efficiency drops. But this car behaved differently. The longer it ran, the smoother it felt, almost as if the system needed time to synchronize. Acceleration improved. Noise levels dropped. The motor sound softened from a faint buzz to near silence. One of our testers described it as watching a machine learn how to run. Maxwell suggested that the RF harvesting system becomes more efficient once it aligns with ambient frequencies, but whether or not that explanation is accurate, the sensation was unmistakable. Every round made the car feel more refined. Even the steering response became cleaner, as if the car had shed mechanical resistance. By the 15th minute, the entire team stood around the road, watching in disbelief as a machine appeared to break the rules not just once, but continuously. It didn't feel like a car running on stored energy. It felt like a system feeding itself better the longer it operated. When we reviewed the data, the trend was clear. Stability increased over time. Efficiency increased, noise decreased. This wasn't decay, it was evolution. The final discovery wasn't technical, it was philosophical. Standing there, having witnessed all 6 previous anomalies, one truth became unavoidable. If this technology works at scale, it challenges everything we know about energy. Not just engineering, but economics, not just mechanics, but politics. Not just efficiency, but possibility. Self-powered systems don't fit cleanly into our current models. They don't rely on fuel supply chains, grid connections, mining operations, or charging infrastructures. They ripple outward, reshaping industries that depend on scarcity. This wasn't just a car. It was a question directed at the future we think we understand. Some will doubt it, many will reject it, but none can deny what we saw, a machine that operated in a way no car should. Whether it's a breakthrough or an unexplained phenomenon, it forces the conversation. And maybe that's the biggest discovery of all, the realization that innovation doesn't wait for permission. It arrives quietly, unexpectedly, in places where no one is looking. And when it does, the world has to decide how to respond. After driving Maxwell Chikumbutso's self-powered car and documenting these 7 discoveries, one thing is clear: this machine doesn't fit into any category we already understand. It behaves like technology from a different timeline, one where energy isn't owned, controlled, or rationed. Whether you view this as engineering genius, experimental physics, or an unexplained anomaly, the experience forces us to rethink what's possible. If even half of this proves scalable, the world is about to shift. And maybe, just maybe, we witnessed the first spark of that shift today.